In this video, we're going to talk about how you simplify complex fractions, which corresponds to section 7.5 in the text. So there are two different methods that I'm going to show you for simplifying complex fractions. And the first one is using division. So a complex fraction or complex rational expression is essentially a fraction that contains fractions within the numerator and the denominator. Right? So it contains these rational expressions, which are fractions in the numerator and the denominator. So there are two ways of going about it. The first one is using division. And in order to do this, you just need to consider the numerator and the denominator separately. So for the numerator, we have 3 plus 4 over x. Now, if we were going to add this, first thing we do, anytime we're adding fractions, is what is the LCD? You're right, it's x. So this is really 3 over 1, so I multiply both the numerator and the denominator times x here. And then what I'm really adding would be 3x over x plus 4 over x, which gives me 3x plus 4 divided by x. Okay, so that's my numerator when it's all simplified. Now we do the same process for the denominator. So I have 2 over 3x plus 2 over 3. What's my LCD here? Yep, it is 3 times x. So this already has a 3, but it's missing the x. So we're going to multiply the numerator and the denominator by x. And then what I'm adding is 2 over 3x plus 2x over 3x, which gives me, I'm going to write it as 2x plus 2, that's the way I'm used to writing it, the x part first, over 3x. Then, once I have simplified the numerator and the denominator separately, I bring them back together and I divide. So my numerator is always first, so I have 3x plus 4 divided by x, and I am dividing that by 2x plus 2 over 3x. But you know that when we are dividing fractions, we actually invert and multiply them. So I have 3x plus 4 over x, that one stays the same, and I'm multiplying that by 3x over 2x plus 2. Now, if I can simplify, I need to, okay? And that sometimes involves factoring. So for example, this denominator here factors into 2 times x plus 1. Now I'm writing it as factored just to see if that helps me simplify something, okay? So see anything we can simplify here? Well, I know I can simplify the x's, so I have 1 in my numerator and 1 in my denominator that are simple by themselves, so we're going to simplify those. And then what I'm left with in my numerator is a 3 and 3x plus 4. And in my denominator, I'm left with a 2 and an x plus 1. I actually cannot simplify that any further, so I just leave it. Okay, so that's the process of simplifying the complex fraction using division. Now let's take a look at simplifying it using the LCD. So that's the second method. When you're going to simplify using the LCD, what you do is you look at all fractions that are involved here. So I have 4 over x, this is 3 over 1, 2 over 3x, and 2 over 3. And I say, what is the LCD for all of those fractions? In this case, it's not too terribly challenging. It is just 3x. So I multiply the numerator of my complex fraction and the denominator of my complex fraction by the LCD. So I multiply this whole thing times 3x and this whole thing times 3x. Okay? So think as if I was distributing this, what would happen? Okay? Well, what is 3x times 3? That gives me 9x. And 3x times 4 over x. Well, in that case, my x's would cancel, and I'd be left with just 12. Okay? How about my denominator? 3x times 2 over 3x. Well, in reality, my 3x's would cancel, so that would be, I'd be left with 2 there. And then 3x times 2 over 3, again, my 3's would cancel, so I'd be left with 2x. Now, this happens to be the same complex fraction that we used in the other example, so I better end up with the same answer. It looks a little different right now. If you're taking notes, we can go back and look at that first page. It looks a little different right now, but that's because I can factor this numerator, right? What comes out of there? Greatest common factor is 3. So that's really 3 times 3x plus 4. And then similarly, I'm going to factor out a 2 from my denominator, and then I'm going to rewrite it, of course, with the x part first. 2x plus 1. Okay, so if you go back and look at that first example that we did, flip back to that other page, I came up with 3 times 3x plus 4 in my numerator, 2 times x plus 1 in my denominator, and sure enough, using the second method here, 3 times 3x plus 4 in my numerator, 2 times x plus 1 in my denominator. So that gives you a couple examples on how you're going to simplify complex fractions. Unless it specifies in the directions as to which method you're supposed to use, it doesn't matter to me. Chances are you'll like one better than the other, but it really doesn't matter. As long as you do the proper steps, you'll come up with the right answer. Okay, keep up the good work, and we'll see you again soon.